my camera had moved. It's very tenuously mounted to the wall, and sometimes gravity, I guess, slowly nudges it down. But the most important thing is I am now center frame, which is obviously the most important part. Hello, everyone. Hello, hello. Farand, Queco, Connor, Mysterious. Hello, hello, hello. It's a bit... I wouldn't put it past the cats to jump on there, but it's quite... Especially when my desk is lowered, because the camera is mounted such that it's in the right place when the desk is up. So when it's down, it's quite far, so I don't think... There's better things for the cats to jump on. Harand, no worries. It is graphics programming today, so you will be missing out on that, I'm afraid, but hopefully you can round to answer my many questions. Abduram, hello. Chrism, hello. Apologies for not being around last Sunday. I was not feeling great and thought 2 hours of standing up and talking C++ would not improve the situation. Whilst I'm normally a proponent that the C++ is a cure for all ills, couldn't quite take my own medicine on Sunday. Betty, hello. So we're back today with a vengeance. Okay, so let's start, question mark? All right, so first of all, now I feel like I'm massive. No, it's too high. Why am I... What's all this space doing? I look ridiculous. Oh well, whatever. Just don't clip this. Okay, so I don't like to do too much off stream because I feel the whole point of this is really annoying me. I'm gonna have to load this a little bit. Hang on. Better. Right. What was I chatting about? Oh yeah, I don't like to do too much off stream. The whole point of this is to be entertaining and fun and to teach a bit C++ and for me to learn some stuff as I go along and showcase how I solve things, etc., blah, 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 blah. That being said, I did finish off the level editor, or at least to a better part, because I came to the conclusion that we'd spent like 2 or 3 streams on it and it was largely mechanical. Julian, hello. It was largely just grinding out ImGUI integration and not really that fun. So I just sat down quietly on Saturday, so before I was not feeling great, for about 6-7 hours, so like 3-4 streams worth, and I just kind of knocked most of it on the head. So today I want to do HDR and tone mapping because I think that is fun and interesting, and I want to do it a slightly different way to the way I did it in the previous project, so that's all fun. But for now, let me show you what we got. Oh no, let me first start Docker. I rebooted my machine earlier. Let us start the Dockers, and once we are Dockering, I can showcase what I'm talking about. Go away. I mean, don't go away. Like, stay hidden. Right. I also did a little bit of profiling to work out why it loads so slow, and if I remember, I'll come on to that later. But that's definitely going to be we're going to fix that not today, but in the not so distant future because it's easily solvable and it's a massive pain. But for now, let's go. Right, okay. So this bit here, not the build time, but this load time is a little bit... Ooh, worked earlier. Hey? Sure. Just add that random character in there. Yeah, this load time is because it's all the ping passing. It just takes bloody ages Right, okay. So we got this, right? This is pretty much what we've seen before, okay? But now, let me just come out here. So when we open up the editor, this is slightly different now. So first thing I fixed was the log now has a proper auto scroll, and this will scroll to the bottom, and if you scroll up, it will disable the auto scroll, and if you click that, it'll scroll to the end. So the logging is now useful again. I added a visual identifier for the lights, so you can now click these, and so the global light, the global ambient light is still here, right? So you can still change the ambiance, okay? But now you can click on a light, and so now we have the inspector on the right. So rather than it all kind of overgrowing here, this is just the scene on the left, and then the right is the individual inspector. When you click off, it goes away. So we can now move the light around, and then when we change the color of the light, it also changes the little light handle for it as well, which is quite nice. And then we can change all the individual things. So that's cool. And we can also add a new light. So this allows us to add like more. So it didn't even support multiple lights before, so I had to go and add all that. Lower that down. And then same, when you select an entity, you get, this is just the transformation matrix mode. There's nothing else really to show for it. I also added the snapping. So this now moves a set size. So if we add a new one of these, then we can move it, and it will always line up, right? So if I just take this off now and we go inside, seamless levels like that, absolutely seamless. And then when you only get these debug UI, these are debug UIs, right? So you can only see these in the debug mode. Fun fact, I was loading all the textures upside down, so all these pipes now look different because they're now correctly textured. Didn't realize that until I fixed it. Yeah, so that's kind of where I'm at now. So I wouldn't say it was like, I suspect the normal maps are upside down as well, I just didn't notice. Because this is really the only thing that's kind of normal mapped. Anyway, it was a little bit of a refactor, a little bit of like mechanics. I wouldn't say, I don't think we missed out on much by doing this as a group, as a team, because it was largely just mechanical, but it could have taken me like another 2 streams, you know, because I'm, no offense, I'm probably slightly I'm probably slightly quicker when I'm not streaming. Nothing went really wrong. It was all kind of fine. So yeah, that's why I don't feel too bad for doing it, and then we can absolutely like hammer those more lights now. So this is interesting because this is the problem I want to solve today. At the moment, we are still, although we render to a floating point frame buffer, we just cap everything between 0 and 1 at the end of it. Yeah, exactly. The editor now is kind of in a really good place, I think. So you can't remove lights, you can't remove entities. There's still other stuff we'll do ad hoc as we go along, but for now, like, this is kind of in a pretty good place. So yeah, you'll notice that all the lights cap out right at maximum brightness, white, because we're effectively in the LDR, the low dynamic range space. So what I want to do today is do HDR, is properly add HDR and tone mapping. So the idea is that we have floating point frame buffers, right? So let's take a step back. Traditionally, like when you're just rendering to a frame buffer, your pixel value is between 0 and 255, right? So it's got one of 256 values, right? Or 0 to 1 F, depending on which way you look at it. Oh no, sorry, it's bytes, right? So 0 to 200, 0 to 255. That's great, but the problem is though, if you accumulate more light in either R, G, or B than the value 255, it just caps out. And this is what's happening here. I have too many lights, and it's absolutely capped out at white. We can enable a floating point frame buffer, which is actually what we have here. The frame buffer we're rendering to here has between 0 and, well, it's half float, but max 16-bit float, right? Loads of values. But at the end of the day, your window, like the actual display, still expects a value between 0 and 255. So all that extra information that you're encoding at the moment, we're throwing it straight to the sea. Like it's gone. Like we're just like sacking it straight off. So what we can do is we can do something called tone mapping, where we basically do some clever maths to say how we want to map those massive range of values back down to the lower range, because we still have to end up with a value between 0 and 255, right? That is just because we don't have a HDR monitor, right? That is axiomatic. But what we can do is we can basically say, oh, well, we would prefer to preserve, I don't know, the high tones or the mid tones or the low tones or whatever. In the last project, we did this and we used something called the Reinhard tone map, which is basically my first tone map. It's super simple maths. I think it's like one, like an addition and a division or something like that. Whatever it is, it produces like a kind of okayish result. I think it looks quite Reinhard-esque. The reason I'm kind of partial to that is because one, it's easy, and two, Reinhard was one of my lecturers at university, so just drop that in there. Other than that, like, that curve's now dead to me. We want to do something better. What I want is more artistic control. Not that I am in any way gifted in that area, but what I want is dials that I can tweak to kind of come up with some aesthetic that I think looks okay. So what I want to do this time is use the, I think it's the, and let me just check the correct name. It is the Uchimura curve, which was used in Gran Turismo 2. Okay. And it looks like this to start with, and here's the maths. Okay, bit more maths, but it gives you these dials, so we can be like, oh yeah, I want that to be like that, and that to be like that, and like this to be like this. I couldn't tell you exactly the specific meaning of all these dials, but what we should be able to do is have these within GUI sliders and have a play around and see what we come up with. I think it might be a little bit more fun than what we had before. And the idea is then eventually we could serialize those, have them saved as part of, when we bring the game back, and then we could have like a consistent feel as part of the game. That is step one, which I would like to get done today, although it's been 15 minutes in and I'm still talking. Step two is exposure and dynamic exposure. The human eye as a iris, right? It opens and closes to let more or less light in. And you can actually kind of model that in OpenGL. The idea being that if we look at something really bright, we want to change the amount, we want to change the exposure, we want to change like how aggressively we brighten and darken the pixels. The idea being that if you move from bright to dark areas, the world should slightly adapt as you go along, rather than just having to, otherwise you'll end up with, you kind of have to pick if you have just a static exposure, then when you go into either really bright areas or really dark areas, depending on how you tweaked it, it'll either be really bright or really dark. So you either have to lower all your lights to some sort of average, or just suck up the fact that some areas of the game might not look great. Whereas if you have a dynamic exposure, we can per frame calculate how bright the scene is, the luminance, and then dial that into the tone mapping calculation. I don't know, it sounds good to me. I thought of this earlier. I thought that I've never done that before, so why not do it live? So we got a plan. Let's start doing. So let's do. I guess we'll probably should start off with a new branch, right? So new branch. Let's do a tone mapping. Nailed it. Okay. In this situation, what does look at mean? Like what the average brightness of the scene, right? So if you're looking very close, if there's like a big dominant bright light, then everything around it will be bright. So the average luminance of the scene will be bright. So you actually want to lower the exposure so you don't lose the detail. We're trying to stop stuff getting washed out or crushed down to black, basically. Hello from UK to Germany. We'll give it a go. I think it will become more obvious as we do it. At least I'm hoping it'll become more obvious to me, because it sounds great in my head, but I'm not a graphics dev. So first thing we need to do is something linear space, something logarithmic space, something color theory. We need to make sure that at the moment, OpenGL is pre-processing our textures as they go in to make kind of the maths kind of work, but we're going to need to, because we're going to be tone mapping and gamma correcting, we need to undo that. So we need to mark all of our textures as sRGB, which stops effectively, I guess, like Is that like a pre-gamma correction? I don't know. I can't remember the specifics. There's an article somewhere on like what every programmer needs to know about gamma. You should go read that. It. Apparently I reconnected successfully. Hello, anyone out there? This is not me. This is not me trying to fake engagement. I do need someone from Twitch and YouTube to write in the messages whether you can still hear me or not. Okay, fine. That was terrifying. Okay, right. Well, I wonder if I think so. I do have a wired connection, but I seem to have defaulted back to the Wi-Fi. But I'm worried if I switch that off, things are going to go bad. So we'll just keep on trucking. Okay, so texture data. So at the moment we have RGB, RGBA, RGB16F. I think we need here to basically have to say sRGBA, and maybe sRGB. I think that's right. And then when we do the graphics utils, is it here? Somewhere where where do we load the textures from the models? Is that load text? This just returns the file name, doesn't it? I think it's in main, where we go through all these. Excuse me. Nope. Where do we load the textures from? That's where we load those ones. Where else do we use add? Text manager, here we go. Here we go. We create a texture here. So for the so everything data related should remain the same because it represents pure data. But in the case of albedo, so where do I get this? Oh, do I? Oh, it's texture data. Where do I set that then? Yeah, that's all well and good, but where yeah, where does that get set? Ah. Oh, load texture, here we go. So here I need to basically say whether it's going to be the sRGB or not. So at the moment, we basically just say, hey, give me the number of channels, and we do this. So now we also need to do something like, this is an internal function here. So bool is sRGB, and then in this case, return is sRGB. That or is sRGB sRGBA RGBA. I think that's all we need. So now obviously we're going to have a whole bunch of other issues as well. I think for one here as well. No, where do we do we not have a 2-string for this? Trying to do this bit at a time. This is going to be a little bit of scattered all over the place. Here we go. Case sRGB. Case sRGBA. Return sRGBA. Okay. So then channels to format is going to be ill-formed because we don't have study. Is this the only place it's called? Okay, so how do we infer from here what we're doing? I think we're probably just going to have to tramp the data down. It's not the end of the world. And then here, ugh. What did I just paste another function? Did I paste something? Oh, good spot. Good spot. A little bit heavy, fat finger today. Okay, and then what we can do here is do const auto is sRGB equals type equals AI texture type base color. So only the base color should be this. Everything else is basically data. I think that's... obviously the texture code won't be set up to handle this yet. I just want to just kind of see what we're dealing with. I don't think OpenGL is die. Is OpenGL dying? I mean, no, I don't think so, because I still think it's an excellent way of kind of learning graphics programming. Because the alternative really, I guess, would be DirectX 11, which is Windows only. So if you're on Linux or even Mac up to OpenGL 3.3 and you wanted to learn some graphics programming, OpenGL is still your only choice, really. So I still think it's pretty good for that. And I still think, I mean, I'm hoping through this project we can prove that we can get something reasonably efficient and looking reasonably good with OpenGL still. As in, like, I don't think the project would be any... My goal is hopefully to show something that wouldn't be any better if it was written in Vulkan. No previous declaration. I don't understand. Missing dex. Oh, that's a public function. Oh, interesting. I didn't realize that. I thought it was an internal function. You're right. Right, you are. Right, you are. Computer doesn't lie. Texture CPP. A few people from Germany here say hello. Okay, so now, Christ. Is that not... That's RGB8. Tone mapping and HDR. Probably sRGB. Can you not have an alpha component? Or is it... Oh, hang on. Is it... Is it S norm? And this should be... S norm. That. Is that right? Is it S norm? No, it's not. It's, I was right. Sorry, I'm looking this up on the fly. I think it's sRGB 8 underscore alpha 8. Yeah, there we go. sRGB alpha. Obviously. Yeah. Sorry, you're right. I couldn't remember the runes. Main. What am I doing? 186. False. False. True. Right, got you. The alpha channel is still linear. I think that makes sense. So they should run. Okay, fine, never mind. I was going to say they should run look the same, but obviously not. Invalid texture type and format combination is not valid in 178. Interesting. So it goes from 178 to texture. What am I missing? What am I missing? Can I look up what I did last time? Because I had this working in the last project. I just can't remember what I did. I should have looked at this before. That was in my hubris. I chose not to. I was like, oh, the sRGB stuff will take like 5 minutes. So here we go. Here's what I had from the last time. So I had a similar to OpenGL thing where if it's RGBA, then we use sRGBA alpha 8 and alpha one size, and then what's this? Valid usage. Oh, that's to basically say whether it was sRGB data or data. That's fine. Oh, do I always have to upload it as RGB? Interesting. Okay, so you can't. So when that's false, I have to still return GL RGBA. I think that's right. I think that's gross, but I think it's right. Yeah, you can use default args in C++. I tend to avoid them. They can be a little bit confusing, and I tend to prefer using overloads, but you can do. Okay, fine. So that works. I think it's already darker, isn't it? Because they would have been pre-gamma corrected. Anyway, exceptions are the correct way of communicating errors in C++. Like I don't know what to say. So let's do enable sRGB textures. Okay, so that commit, yeah, okay, fine. So now we need to, let's add a new post-processing step called tone mapping. We'll probably just get it just to grayscale it or something to start with to test it works, and then we can go through and start adding all these parameters in that we want. Exceptions are people fear what they don't understand, right? And people don't understand exceptions. Modern architecture, I guess, or most operating systems or platforms that you're using them on, they are basically free to not throw, but expensive to throw. At which point you are probably on the unhappy path anyway. So the extra runtime overhead, I would say, is generally irrelevant to the simplicity that you'll get in the code. That being said, like if you are in like a hot loop somewhere, then they may not be suitable. Everything, be pragmatic about everything. But if you're in a hot loop, you're probably making other concessions anyway. You're probably not using malloc. You're probably doing other things. So yeah, that code, that highly optimized hot loop, might look different to the rest of your code anyway. However, as a way of decoupling the code that produces the error from the code that handles the error, I think exceptions are the correct choice. It's new age, it's new dawn, it's new day. We're going to get const expra, except 26 has const expra exceptions, so we can even we can either have proper error handling in one of our const expra code now, which is exciting. That's my thoughts on it. You are of course free to disagree and code however you want to code, but I prefer exceptions. Okay, what am I doing? Renderer. How can you only have the exception handler in the debug build? Like, would you just then just throw and just calls to terminate? Like I said, like you gotta be pragmatic about everything and know your architecture. I think for most stuff that most C++ that you use now, as a general sweeping statement, I think exceptions are fine. Okay, so we now want a render target tone map RT. So we will basically in the renderer, and we'll go through this in a second, we will produce the G buffer. So that's the albedo, the normal, the specular, and the screen space positional data. We will then combine that all together with the lights to produce the final untone mapped floating point buffer image. That will then go into the tone map, which will then produce, which will then tone map it down. Apply the tone mapping curve, and then that will then get copied to the back buffer, which will then get flipped to the screen. I don't think we need any more buffers at the moment. I'm just going to shove everything in uniforms. Don't need any new command buffers. We can reuse the existing post-processing sprite. That's all fine, and the post-processing command buffer. I think the only thing is going to need a new program tone map program. I think there's any primitives we're going to need. I'm not sure. I assume the render target can just be an sRGB frame buffer. There's no need for it to be floating point because the whole point is we're downscaling anyway. Buffer of the buffers, not yet. I did conceive the other day I did have the brief terrifying thought of taking all the managers and putting all those in one place, which then the only name I could come up with was manager, and then I immediately stopped that train of thought. Okay, so we're going to need to do what we've got. We've got so the tone map program will be the tone map vert These are all things to come. Tone map frag. Ass. Nope. Absolutely not. Tone map program. I am not being consistent with the things that I've called passes and things that I have not, but what are you going to do? And then C2T tone map. That will by default create a floating point frame buffer. I think we'll just optimize that later. I want to do an optimization pass over all this anyway. Once it's not like that. No. I typoed it here. Tone map. Well, always an extra comma. Either an extra comma or a missing curly brace. Okay, fine. So now we can start wiring this up. So we'll see here. I'll go quick top to bottom of the renderer because it's quite interesting. So first of all, we create the we clear the G buffer. We use the G buffer program. We write the camera buffer data into an SSBO. We bind that. We bind the camera. We bind the global. So all the vertex data is all in one big array, and we do something called vertex pulling. So we pull from that. So all the vertex data is bound. The camera data is bound. We bind the index buffer, which again is just one big array of all the index buffers. We create the command buffer because we're using MDI, multi-draw indirect. So we produce a buffer of draw commands CPU side, and then we bind that as the indirect draw call. So then OpenGL so OpenGL can know what to actually draw. We populate the object data with all the scene objects. We bind the buffer, write to it. That's it. Yeah. And then we set the global material array. Everything on the GPU is just massive global arrays that we index into. So all the draw commands are shoved up there, the materials are shoved up there, the textures, because we're using bind as textures, and then our entire scene, right, is our entire scene, our entire G buffer, right, is filled with just one draw call, which is pretty nice. GL multi-draw elements indirect, bit of a mouthful. After a while of staring at it, it does actually do what it says on the tin. At the moment, we draw everything. Just the whole thing gets over there. The future optimizations are... So everything is static at the moment. So once we do dynamic objects, so ones that kind of move throughout the game, so either via the physics engine or via animation, I will then separate those out into static elements, which are basically loaded at the beginning of the scene and will always be drawn. So it'll be one fixed set of commands, and then a dynamic command buffer, which will be for the dynamic stuff. Then, once I've worked out how to do compute shaders, I will probably I'll probably add a compute shader before, like somewhere like before here, which will filter down that command list to just the ones that the game knows are visible. So we'll do basically GPU side frustum culling, which will then be a lot more optimal. So yeah, but at the moment we just there's 9 things to draw, so it's not a lot. So we shove all that straight into the GPU that does it, and then we clear the light paths, we get all the lights, we copy all the light data into another SSBO, and then here we bind, because everything is because we bind as textures, right? All the textures just exist in a massive array on the GPU. To tell the light pass where the various inputs it needs are, we just give it the index, right, of where the various color attachments from the previous multi-render target outputs. Bind all the same shit as before, blah, 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 and then we just do one multi-core, multi-draw. This is a bit overkill because I think the command buffer has just one command in it, but it was easy to reuse it. Do any post-rendering stuff, which maybe have ridden with a debugger, with a debug renderer, and then advanced all the triple buffered buffers, blah, blah, blah. And then at the end, we just blit it. Hello. So yeah, so what we need to do now is, after we've done this, we can now do basically the same thing again, right? So I don't need all those uniforms yet. What I should be able to do is do these will need to be pulled out into separate functions or something at some point, because this is going to get a little bit unruly. But for now, we can kind of get on with it. So anything that's light pass now should become, so C2FS will become tone map RT, bind that, use the tone map program, and I think we're there. We don't need the texture manager. We don't need access to the textures because it's tone mapping, right? We're not passing any textures in. We don't need access to the lights because that's already done. I don't think we need access to the camera data either, because we're just working off of, which is post-processing effect. So I think that's all we need. And then I think what we need to do is change it so that C2FS light pass here becomes, this could probably be abstracted. We should probably have like a pointer or something to like the fact. I wonder if I should just do that now. Light past. Frame buffer. Final FB. Just because this is, whatever the final step is after all the post-processing effects is the one we need to blit. And I just feel like at the moment it's light pass, and now I need to upchat. I was about to retype that out to be tone map, but I feel like this is just going to change every time. So if we do light pass C2F dot with final FB, and then we can do up here after this final FB equals tone map RT dot FB, right? So this is just means it's I only have to change it in like one place rather than loads of places. We'll see the output in a minute. We'll see the output in a minute. Like I say, this function is a little bit long now. It should be broken down. So then now I just need to write some shaders. Let's go copy assets, shaders, light pass vert to assets, shaders, tone map dot vert, CP, might as well frag assets, shaders, tone map frag. So we need the vertex. So again, this, we just pull in the vertex. So there's no GL attrib pointer, all that bullshit. In older OpenGL, we basically just mirror the structure in OpenGL is in C++, and then we just squirt all that data into the GPU, and then we can just pull them in, which is quite nice. So I don't think I need any of this bullshit. I think I just need to do that. In fact, I don't actually even need this. Thanks. Enjoy your sleep, and we'll see you later. Yes, I'm going to... Tone map function is going to be Uchimura, the Gran Turismo one, just because I like the idea of it's a little bit more configurable than the other ones, and I really like sliders, and I really want to slide stuff around and see stuff happening. So tone map frag, so I need the vertex data because it's already bound, but I don't need this. I technically don't need this. Go away. So I think all I need to do is basically... Oh, I do need access to the texture, don't I? Because I'm sampling it. Well, what a fool. What an absolute fool. Otherwise, what am I tone mapping? Come on, guys. You should have seen that. And then I will just need one index, which is the input text index, the thing to tone map. I'm undecided about sliding. Have I got... 1 second. When I moved to this new PC, I can't remember what line of code tool I used. So it's slot count. I think it's... where's the total? There's a different tool because I can't remember what tool I used before. 7,000 lines of code. Not bad. Anyway, quick. No, don't use an engine. We're building it all from scratch. Yeah, I don't know. I've never used anything other than Reinhardt, and Uchimura was just the first one I kind of saw that looked configurable, so I thought we'd give it a go. Indeed, from scratch, not in scratch. I'm undecided about sliding because I really want to model... My idea is I really like the movement and feel and gunplay of like the original Halo games, and I think that's kind of something that I would want to kind of spiritually channel, and there wasn't any sliding in the first Halo games. So obviously I'm not saying I'm going to be able to recreate that, but I think there's probably enough information around there about the kind of the feel of it to kind of get some parameters to plug into Jolt and see how we get on. I'm going to need the UVs as well. God damn it. I'm going to need literally everything. What a fool. So in color, it's going to equal textures. I'm going to call this, try and keep it consistent. Oh no, actually I can't do that. Input text color, yeah. So input text color. It's hard to have tutorials for reverse engineering because there's so much more, because you're trying to undo a lossy process, so there's so much context-specific stuff that you need to be aware of. You know, like the platform, the architecture, the compiler, the optimizations, the intent, any latent bugs that are in there. Whereas I think it's easier to write tutorials for programming because it's a lossless, not necessarily lossless, but it's easier to write a hash function than it is to write something that goes backwards from a hash function, right? That's kind of the way I look at it. It's easier to put something into the black box than it is to pull something out of it. So in color is this, and then I should be able to do something like in color dot ggg. Let's just, I don't know, like grayscale it. That would give you actually a rough approximation of the luminance as well, because your eye is more sensitive to green. But that's neither here nor there. I think that's all I need now that I kind of know what I'm talking about. We're going to have the input texture. We're going to have the... We don't need the frag position. That was definitely needed for the lighting calculation. So let's make that 0. Go back to the vert and kind of undo everything I did. Okay, fine. So, one handle. There you go. Right, that's what we need. And then I need to go back to the renderer and rebind some stuff that I was like, don't need that. Like a fool. Okay, fool. So I'm gonna need, I think I just need this here. Right, let's give it a go. This will work. I press the button. We'll see what happens. I've been a little bit lax on shorts just because I just feel like I've been chronically short of time at the moment. I have a bunch. I think I have like 10, 12 shorts just unlisted on YouTube. I just need to schedule them. But I want to kind of build up a bigger buffer because I've got some time off coming up again. Spoiler alerts, I've got some time off coming up again. So I want to make sure I've got enough shorts to kind of power through that. Nailed it. Oh, I know exactly what. I was such a bloody fool. Got to actually set the bloody uniform, haven't you? So this will be light pass RT first color attachment. Probably don't need that. Just whatever undefined behavior that uniform was. Good job it was a happened to be a valid texture, otherwise that would have crashed. Yeah, I'm going to put in a fixed exposure slider to start with, and then I'm going to go on to do dynamic exposure based on the average scene luminance, the average frame luminance. Not long enough. It looked like it was great. So it's definitely... Why is it sampling the room? So many questions. Oh, just open up RenderDoc. Line 2... What about line 278? Yeah, I want... Ah. Yes. 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 You're so right. The big... Such a Burke. Okay. Yeah, I could run Neovim as a native Windows application, but then I won't have tmux. And then what are you going to do? Okay, that looks good. I'm presuming if I make everything red and then green, it'll get brighter, and then yeah, cool, nailed it. Woo! Okay, fine. So that's the... I'm just going to commit that, I think. That seems like a good commit. It's like initial tone map pass integration. Okay. Right, now, maths. Maths. Gem. So I need some more inputs. What's the best way of doing it? Lazy git. Oh, is there a 404 git? There's 404. It's true, yeah. We have to contend with more than one math. Let's. I kind of want to just see this all happen at the same time. So let's go to scene. Let's just delete that code. Scene. We'll do time. Loads of time, mate. Loads of time. So let's do struct tone map options. And then we're going to do float. Definitely float big P. Float A. Float M. I think these have meaningful names. Yeah, maximum brightness, contrast, linear. Yeah. I've got to call these. I can't be calling them that. Because I'm gonna have to call them these in the GUI anyway. Linear section start, float, linear section length, float, black tightness. Apparently I have 2 for that. I think the last one is float pedestal. And then we'll have exposure later as well, but I'm going to add that later. I just want to get this done. So, so scene will then have a tone map options. Tone map options. We will have a const expra auto tone map options. This auto self return self dot tone map options. Give us either a const ref or a non-const ref to it, depending on what we've been called on. And then we also construct ourselves with a tone map options, scene tone map options, tone map options, and then tone map options. I'll stub move it, although it technically doesn't make any difference because it's an aggregate type. Well, sorry, they're just all pod types. Trivially, no, you can't use pod types anymore. What are they called? Trivially copyable. The move is the same as a copy in this case. But it's fine. Okay. Main, because it's going to be unhappy. Main is always unhappy. So let's do, I'm going to take the default values from this site and assume they are correct. So dot max display brightness equals 1.0 f, dot contrast equals 1.0 f, dot linear section start equals 0.22 f. Gotta be careful with that one. Dot linear steady. Linear section length equals 0.4 f. Dot black tightness equals 1.33 f, and dot pedestal equals 0.0f. I think the term changed because just the standard changed. I don't think that it uses the term plain old data anymore in the standard. I think it has another name which is slightly different, probably encompasses something slightly better, but I can't remember. It's like I don't think there is pod, or do they get rid of that? Yes, he stood his pod was deprecated in 20. I wonder if it actually tells you what changed. Deprecated. See, pod is not since 2+20. Pod is no longer a thing. More refined type requirements: trivial type, scalar type, or standard layout type. That's it. I think pod type meant too many things, so they split it into 3 separate things. Because the one thing you need in C++, the one thing every version of C++ needs, is more terminology. Yeah, it was trivial type and then the scalar type. So I guess it's a scalar type. I guess you could have combinations of those, right? But yeah, that was my understanding of it. Okay, let's go to debug renderer and let's wire in some more MGUI stuff. I want to get those sliders going. Even though they don't do anything, I want to get those sliders going now. So let's add them. I can't see why there's no reason not to add them, like just here. So if MGUI slider floats. Here we go. So we've got a label, min, max. It's annoying, you have to have the out value as well. So we're going to do const. Oh no, we're not going to do const. We're going to do auto value equals scene dot tone options dot whatever the first one was, maximum brightness. Ugh, I hate everything. If MGUI slider float, when we get reflection, then this is 0.0f and 100. So they all have different min and maxes, which is a little bit annoying. I could write a custom type which also encapsulate a min and a max and kind of enforce that as a predicate, but that's just a lot of work at that point for something I only need in a debug layer. Then this would be scene dot tone map options dot max brightness equals value. Let's check that works. I'm trying to add tone mapping, but I'm obviously going to do it in a non-trivial, slightly complex way, because where's the fun in it otherwise? Hash include tone map. Right. That looks good to me. Whee! Ooh, I need to... That's too big. There's obviously some... I want to make that smaller, but I guess is that line to that? Oh, well, promise for another day. Okay, right. Watch as I just grind these lot out. Max brightness becomes contrast, becomes contrast, becomes contrast, and this is between 0 and 5. Definitely don't want to be having too high contrast. No, I just have some notes off screen. Like I've got this. I have a pretty large monitor, and I only stream the top right hand corner of it. So I have 75% of my monitor is for like stuff. Stuff. Right, let's. Sorry, this is boring busy work. This. Linear, linear section lengths. Oh, and I've not been checking these max values. So that was between 0 and 5. This is between 0 and 1. Linear section length. Linear section lengths. And linear section length. And this is between also 0 and 1. Right, 2 more. Let's bash this out. So this is now the black tightness. This is between 0 and 3. This is just according to like the literature, right? I've absolutely not done any of this from first principle. And then pedestal, and then that is between 0 and 1. So let's just check that works. It's also in the Denuvo video. Let's not forget that. Yeah, it's a 42-inch monitor, 4K, only 60 FPS, but like, who needs a fast frame rate? But yeah, there's a whole lot going on. Okay. Okay, so that gives us some sliders. That all looks good. Those are the default values. I mean, what I'm hoping is not too long we can see these, what effect these actually have on the thing. And as we have more lights, what effect that has. Linear between them. Yep, good spot. Thank you. Glad someone's paying attention. Yeah, I think ultra wide is in my future. Maybe even this year. I think getting a nice big ultra wide high frame rate. What am I doing? Right. I suppose I better actually do some work now, rather than just farting around adding ImGUI sliders. Right, let's do... So all these now need to be uniform. So layout... I'm tempted to... I might call these by the letters here, just because I'm going to be cribbing off the maths here, and I'm worried that I'm going to get really confused if I don't follow their system. It's not great, but I'm going to have to use the U predicate as well, which is now different to everywhere else I've done it. But otherwise, just having a random global variable called A, it sounds like a recipe for disaster. So how many of these do I need? 1, 2, 3, 4, 5, 6. And then we got A, M, L, C, B. I need to do gamma as well. Fuck. Uh, oh, wrong place. I want to put this at the bottom. Give me 1 second. Hold on 1 moment, caller. I don't know what like a maximum gamma you'd want is. 5? This is capital P because that is what the math uses. I don't know, I'm not Uchikuma. Your guess is as good as mine. I've done tone mapping once before. Okay, so let's now do Vec3 Uchimura Vec3 in color. So then I should be able to do Uchimura Vec3. As simple as that. As simple as that. Right, so float L naught equals P minus, oh, hang on, I need more brackets here. P minus M times L over A. Yes, I know. What's the... I feel like I missed something in chat. Oh yeah, I do. Thank you. I don't know what I'm doing. I'm making this up as I go along. Right. Float. Now, not to be confused with L0 is also L0, not to be confused between the two. Scroll down and it gets a lot more complicated after this. And then you've got float L1 equals M UM plus UA times UX minus UM. And then, okay, so we've got these. These are constants, right? We could probably even pre-calculate these. And then I've got L of X equals M plus X plus A. Okay, at what point do I put in like my color value? Where's the input? And I assume do I apply this to each channel? Like, the fuck is all this? Should I have found a GLSL? Uchikura. GLSL. Uchimura. Uchimura, here we go. Oh, this looks hot. Look at all this. He's done everything I've done. I could just. What's the license for this? Guys, unloads. MIT license. Oh, that's ripe for the pilfering. Why is he Uchimuring multiple times? Those look like sensible defaults. Oh, I see. So if you call it... Does GLSL have overloading? No. Surely not. Surely not. Anyway, what he does is, if assuming he does have overloading, you give it the color, and then he picks the sensible defaults, and then in. Bindless textures are so within OpenGL, like traditional, well, OpenGL sort of 3 onwards, there was like texture slots. You could have so many texture slots in the GPU, and then you had to bind something to them. So it's like a state machine. You're basically saying, hey, I'm going to render, and then your shader will be like, I'm going to use render slots 0, 1, and 2, and then you'd have to bind something to those slots on each call. And there's just a lot of overhead in that. There's a lot of driver overhead. There's a lot of error checking. Bindless textures basically throws that all in the bin and just says, here's all the textures, like way more than the number of slots, just in a massive array on the GPU, and then you just index into them. It's a lot faster, it's a lot more efficient. The downside is that if you index outside of that array, you will, I don't know, maybe crash your GPU. It's certainly going to be very unhappy with you, whereas all the bindless stuff does a lot of error checking for you, which you pay a price for that. I mean, it's something has to make it resident, something you need a special handle to it. I think there's some, like, I guess the question would be like, what are you making an array of? Because because you only have a sampler type, right, in OpenGL. In fact, you need to make an array of those sampler types. Yeah, you need to make an array of these, right? So you effectively do have an array of them, but you need to do some bit of OpenGL prep to make sure those are, to make sure they are, I guess, contiguous in memory. All right, I'm just gonna. All I would be doing would be typing that out anyway, right? Right? What I can then do is x, then float p, float a, float m, float l, float c, float b, right? And then Uchimura in color up, u, a, um, u, l, uc, ub. I think that's right. You're right, Queco. Can you smell toast? Is everything all right? We're gonna have, I think we're already up to like 20 or 30 textures, so we're using quite a lot. Especially as all the render targets become effectively textures in that as well. I think we're done. This will work. Well, each model has, there's 9 there's 9 models being loaded just now, right, in this initial scene. Each one of them has a albedo map, a normal map, and a specular map. So that's 3 9s, that's 27, plus the nailed it, plus the render textures and stuff like that. So yeah, there's quite a few. I mean, I don't think so, right? Like, surely the whole point of binding textures is you can just have as many as you want. Oh, hang on. Oh, I know. Guys, you must know the issue. Why has no one told me? Anyone want to hazard a guess what the issue is? I don't even have the right uniform function loaded. Oh. Yeah, I'm not saying any of the uniforms. Oh, I do. Oh, I do have it. Ooh, treat myself. Oh. Oh, do I not have the DSA variant? I bet I don't have the DSA variant. One F. One F. I'll just quit Vim, mate. Don't need it anymore. Right. One F. Tone map program. .native handle. 1U. Scene dot tone map options dot. Yes, the order is somewhat important. Max brightness. Yes, I need light pass here because this is the index into this uniform represents the index into the global texture array that I want to pull from to tone map. So I have to tone map the previous pass, right? So this is effectively, this is how I wire up, this is the chain, right? So this is how light pass gets into the tone map. Otherwise, I would be tone mapping myself. Ain't no one do that. Right. Yeah, sorry. I bet it's the right pain when I'm right. It doesn't happen very often, but sometimes I'm right. Oh, I need to do the gamma correction as well, don't I? So that is X3. tone mapped color equals and then Vex3 gamma corrected equals how tone mapped color Vex3 1.0 over gamma. I just copied that from the previous project. It's just like the runes for gamma correcting. Yes, also, why did it not... What have I done wrong? Gamma. Oh, is it U gamma? No, U gamma and U gamma. Everyone gets a gamma. To get the automatic gamma correction, you have to enable it in OpenGL. There's like an OpenGL enable gamma correction, but I've opted to not do it because I want the finer grain control. I think it just picks the default value of 2.2, but I do want it to be toggleable. But yes, you're right, you can get OpenGL to do it for you. That looks tone mappy. I guess that what's... that makes no difference. That... Oh, there's definitely contrasting. The maximum brightness seems to make absolutely no... Oh, is that like a cutoff? I don't actually know what any of these do is the problem. That definitely shifts the contrast, which is cool. Okay. Not convinced about that one. Ooh, don't care for that one. And then presumably the gamma does shift it. Nice, okay. Yeah, so if let's add a bunch of lights. I'm not convinced that's right. I need to double check that. Lower the contrast. Okay, I feel like it's kind of there. It's still clipping a little bit. I don't know if that's just because it's just I just have too many lights. I feel like this should be doing something other than just like turning it off. It's nice being able to affect the contrast though. I feel that's pretty cool. That looks very Reinhardt-y, sort of slightly washed out colors. Maximum contrast. It's like a YouTube thumbnail. Okay, I'm pleased with that. I like that. I'm pleased with that. I feel like we could definitely... There you go. That's cool. That is definitely some fun we could have with this. I mean, it says the max brightness can go up to 100. So what is it? What is that? It's here, right? So it affects L0, which is then used to scale A, great. So it does scale A, which is the... Too many notes. No idea what's going on. Help. Which is the contrast. And then you add it to M, which is the linear section start. But I guess, yeah, if you look at this just like, it just changes where the tail end is, right? So I don't know how you could... None of these will really affect it that much. You can get a little intuition for this, though. That's why raising this makes everything grey, because it basically gives everything an initial value, right? When we were changing the pedestal, everything was getting washed out grey. So that's because everything now has to have at least some value. So that's why that makes sense. I guess the contrast does change, means the colors will pitch up quicker, I guess. Yeah, we need like a good test image. I think someone said HDR. I don't have any of that. We're just gonna have to go on vibes. I think that's kind of it's certainly tone mapping, and I think we can kind of fiddle with it as we go along. Yeah, that's a good point. When we get to bloom, which is kind of on the work, is in kind of on the cards. Okay, so let's do add configurable Uchimura. Okay, so I'm going to start doing the next bit because we've got to do, I don't know how much we'll get done, but we'll see how far we go. So basically, so the next thing I want to do is look at, I'm going to get a lot of rendering words wrong here. So if you're into this, if you're really into this, I do apologize. I'm making up a lot of this as I go along, but this is a great article, right? Automatic exposure using Luminance histogram. I want this. It sounds great. The idea being that you should dynamically change. I want to dynamically change the exposure as we go through the scene. If we're looking at something really bright, we should have less exposure. If we're looking at something dark, then we want more exposure. So we want to be able to bring out the dark areas, but also lower the bright areas as we're looking around. There's multiple ways of doing this. So let me see if I can find it. But I'm going to put this in the chat because this is, if you've never read this, this is an incredible article of the Doom, and there's a Doom Eternal one as well. They take this frame, right, and they basically, I assume they use render doc, and they fully break down how it all works. Like if you're interested in like literally how a single frame from Doom 2016 is put together, it's absolutely incredible. But because they have like a clustered forward renderer. Their normal maps only has 2 channels, which is interesting. I assume they reconstruct the third one from the depth. The SSAO, somewhere they have. Is it here? Distortion map, temporary scene luminance. So the way they do it is they downscale the image to half its size. Then downscale that to half its size, then downscale that, and they keep going until they have a 2x2 texture, and then they use that as a, I don't know why it's 2x2 and not 1x1, because other places I've read it's 1x1, but basically you keep downscaling the scene so it's one texture, and because of the way the averaging works, that is a good approximation of the average color of the whole scene. Sorry if there's issues. I don't really know what, I don't think it's my end. Like I've got gigabit internet, it should be pretty good. Maybe you're right. Maybe 2 by 2 is the minimum size you can sample. But yeah, the idea is that that's how they do it. However, there are kind of different and alternative ways of doing it, and I really want to play around with some compute shaders. So the other way of doing it is the Luminance histogram. So the idea here is that blah blah blah, exposition, blah 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 blah. You bin each pixel into you calculate the luminance at each pixel, and then you stick that in you have 256 bins, and then you increment the counter for whichever bin that is based on the luminance. So you will produce a histogram of how many pixels have 0 luminance, 1 luminance, 2, all the way up to 255. And then from that, you can then write a second compute shader, which will then average all those together to give you a final value. Why not calculate the average of all pixels immediately? That I think it is inefficient to do so, because here you will still have to use atomic operations, but you only have to use atomic operations on 256 bins, and then when you come to do the averaging, you only need a 1D warp, right? Or whatever they call it, warp gate. No, not warp gate. So I think it's more efficient to work in clusters across the whole thing, and then across effectively 1D image into one value. But I'm not an expert. I'm sure if it was more efficient to do it the other way, that was the way you would do it. I'm kind of just going off the existing literature. So I think we're going to start doing this. I don't know how far we'll get, because I've never written a compute shader before, and I suspect there's some gubbins that we need to build. But I think, more importantly, I can't find it now. I think ImGUI has a histogram. So, or there'll be a plugin for it. So I think it'd be cool then if we could at least, even if we don't do all the calculating the average and wiring it all into the shader, it'd be cool if we can just see like a histogram. Obviously, there's a performance penalty of pulling the stuff out of the compute shader, but it'll just be in the debug layer. It'd be cool to visualize if it's working or not. Right, so I haven't really thought much further beyond this, because let's have a think. Okay. Yes, I'm sure there's lots of clever optimization tricks you can do to cut down the amount of data you store. Maybe we'll go through and do them at some point anyway. I have a shader, right? So I assume now I'm going to want like compute question mark. I'm hoping. I don't know if I need anything special around this, or if I can just wang this straight into a compute shader. Again, I've never done this before. I pulled up some brief notes on how to do this. There is on Learn OpenGL, there is a compute shade like guest article, I think. Guest articles 2022 compute shaders introduction. So yeah, this is a good resource. I think this kind of goes through a lot of it. Okay, looks like I can just reuse my existing code, which is good. I don't know if I can just reuse my program though. I guess I could. Oh, because this is going to expect a vertex shader and a fragment shader, but I might be able to overload this. I guess we'll give it a go. Because then use would. Do you still use the compute shader program when you go to? Because you have to dispatch it, don't you? Oh, you still do use it. Okay. So I think this then becomes. We'll basically say if you. If you just give it 1, then we'll assume it's the compute shader. I don't know if that's a fair assumption. Oh, I still need a name, don't I? That thing again where I keep expecting my glass to have more water in it, even though I know for sure it's definitely empty. Okay, let's assets, shaders, yes. I'm gonna get that wrong a lot of time. Histogram.comp. I've been using frag and vert, I guess. Comp. Hash version. Oh, still got some syntax highlighting. That's nice. 460 core. Yes, that's true. Okay, and then I need layout, local size, x was 16. So this is specifying the size of the kernel, effectively, as far as I understand it. Okay, so that basically says what kind of, because the compute shader will work in some configuration over all the data you give it. So this is saying work in 16 by 16 blocks across it, because it's highly it's highly parallelizable, right? So it'll parallelize it in 16 by 16 chunks. You're effectively saying what's the smallest block of data that a single, is it a wave, like invocation works across? Yeah, worker groups. Thank you. And then I need to give it an in. I don't know how this is going to work with my yes, exactly, yes. It's the axes of it's the dimension of the worker group. I guess I'm going to need, I assume I can pull in this, right? Because I've got bindless textures and I hadn't reconsidered this, but can I bring in that? Oops. And then have layout bind equals naught uniform u text index. Okay. Because the thing that I've rendered to presumably exists somewhere. And then I'm going to want. I think there's a bit of math. I don't think it's just as easy as calculating the luminance. I think it calculates it. It scales it. I think it takes it. Does it take the log of it? Yeah, it takes the log of it because the human eye doesn't perceive luminance linearly. It perceives it on a logarithmic scale. So was that doubling the light more than doubles the perceived intensity or something like that? I can't remember the exact maths, but you don't just see light in a linear fashion. So we have to kind of replicate that here. Yep. Okay, so what I think we need to do then is have layout. So then I need a buffer to write the data to, right? So then this will be layout 1, but it won't be read only. Okay, and then this will be the histogram data, and then this will be the uint histograms define num bins be 256. No, not that many. 256. Okay, so I've got some data to write, or I will have some data to write. I'll have to create that as a help, I'm stuck, as a SSBO, I guess, and bind it. And then I need some shared memory. So I think shared memory is located on the GPU, but local to the work group. So I think it's faster. Again, I'm kind of picking up a lot of this as I go along. So they have a shared histogram num bins. Right. I think you calculate the data here and then maybe assemble it, write it back to the global one afterwards. And then, okay, so yes, thank you. Okay, so then what do we want to do? We need to do shared histogram GL local invocation index. So presumably that gives you your current index for your, that gives you your current local invocation index. Oh, there you go. Is a derived input variable containing the one-dimensional linearized index of the work invocation within the work group that the current shader is executed on. Nailed it. So set that to 0 because it's the start. I don't know why I've got like formatting on this, but I don't have on the other shaders. Who knows? Okay, and then barrier. So I think that waits for everyone to kind of arrive at the same point, right? So all the work groups to finish setting all their data to 0. Okay, then I need to 5x2 text size equals, get the texture size of the textures. Actually, I probably could do no, never mind. Textures u did I make the font smaller then? I didn't know. Text index. Can't remember what the 0 does there. Texture size. Oh, my internet is a little bit slow, so I do apologize if it's. Oh, the LOD level. Okay, so that's fine. We only have LOD levels, so that's fine. We don't have any LODs. So what have they done? They've done if the GL global invocation ID dot x greater than text size dot x, and the GL dot y that is greater than text. So I think this is basically saying ignore everything outside of the range that you're currently working on. Yes, right, it should be that. Thank you. Then vec3 color equals, so they've got image load compute. They're using a slightly different language. I think it's the one that gets processed into presumably different compute shader types, so their functions don't all match up to what I'm expecting. Compute shader sample texture yourself. Compute shaders in OpenGL for idiots. I don't know how I sample a texture, because presumably this function is not going to exist. Oh, there is image. Is it image load? Maybe that will work. Oh, image load is a thing. Fine. Oh, okay, fine. Thank you. This does work. So can I use this then? Textures u text index. And they give it a ivec2 gl global invocation ID .xy .rgb. Is that look right? For anyone out there who knows what they're doing? And then so that's, and then you want uint bin index equals color to bin TBC color, and then what the hell are you params? Oh, I see. They have. So you do need 2 more uniforms. You need 1, 2 uniform UINT float u min log, the minimum log luminance, and float u the inverse log luminance range, obviously. Sorry, what have I done wrong? This will load the text from those chords rather than the whole thing. Inserts. Okay, fine. I'll fix the typo first because that's something within my power. Okay, bin index, and then this takes in the apparently these parameters. So basically, I'm just kind of reverse engineer, not reverse. I'm trying to puzzle this out. So this is, I'm just copying from here, right? So they got color to bin. They have 2 parameters x, y, which they've just shoved here, right? And they're just shoving them all in vec4. I'm going to pull them out as separate floats because I think that makes more sense and give them separate names. So that's the u non-index and u. For fuck's sake. Whatever that was. And then we need to do atomic add histogram, shared histogram, bin index 1. So zero everything out in the shared data, wait for everyone to get there, get the size of the texture, check that we are operating within our given area, load the color from that, convert that color into an index, so presumably it will calculate the luminance, then clamp that between 0 and 255, atomically increment that, barrier, and then we atomic add into the main histograms GL local invocation index histogram shared histograms GL local. So that must be accumulating the data into the global one for writing out to it. Why is that not? What's the local invocation index then? Is that like, that must represent the index in the 16 by 16 grid, presumably, because that's how you write that back out to the main data, I assume. Yeah, but like, why am I not looping through everything in the shared histogram and copying it out? Do you know what I mean? That's why I can't understand. Presumably this then gets executed per local invocation, which must effectively be per pixel, which would be per 16 by 16, I think, right? And now we have to, do is do uint color to bin vec3 color float min log lum float inverse log lum range. Okay, so we do float luminance equals dot color with, I'm just going to copy this because I can't bother to type it, this is a good approximation of the sensitivity of each of the RGB components. Your eye is to each of the an approximation of the sensitivity your eye is to each of the 3 RGB components, and it favors green more than the others because your eye is more sensitive to green. Inverse, thank you. I don't know what I'm doing. I'm making this up as I go along. So that's fine. If the luminance is less than some small epsilon, I think this just stops some of the maths going wrong. That's normally why you do this kind of thing. Avoid taking the log of 0. Okay, fine. So I don't like why I must not have editor config set up for this file because it's put in these massive like spaces which I don't really care for. Float log lum equals clamp of log 2 of lum minus min log lum times the inverse of the log lum 1.0 1.0f. Nailed it. Return uint of log lum times 254.0 plus 1.0. I think that's because you can. I know it's done by automatically, but I would much prefer that. I've been very inconsistent with my Fs here. Apologies. It says that the 0th index is handed by this case, so you don't have to account for it here. Okay, nailed it. Bish bash bosh, done. I think we'll. I don't know if we're gonna. Let's just see if it builds first. Renderer. So we're going to want a. I don't going to need a multi-buffer, right? Are we? Because, or are we? I suppose you will be writing to it every frame. So we might want a triple buffer. But you'll have to wait for the compute shader to finish. Right, okay, thank you. So I should be able to just write a... Yeah, that's what I thought. You have to wait for the CPU to finish before you can use it anyway. You're right, this is for if I'm backing it by CPU memory, I guess. So this, let's call this Luminance histogram buffer. Is it Luminance or Luminance? Luminance. And then a program Luminance histogram program. Okay, I think that's all we need. So object data buffer, luminance histogram buffer. This is going to need to be size of the uint 32T times 255. And luminance histogram buffer. Right? Yeah, 256. Thank you. Good spot. I know I'm at time. I want to see if I can get this working though. I'll just be tired tomorrow. And then this isn't going to work for me, is it? Because right, sorry, let's... I just use them to signify to me that they're member variables. It's purely personal preference and just my own convention. Which order did I put those in? The compute one comes second. Okay. Hold on one moment, caller. Right, I think we're getting there. Sample. Why have I called it sample? Jesus. No idea what I'm doing. Compute path. Compute name, compute shader, program name. Okay. Yeah, I think someone already caught that, but thank you for remaining diligent. So this can now be Luminance histogram program. And then this can be shaders, Luminance histogram comp, Luminance histogram shader, and then Luminance histogram program. Is it still 255? Did I not change it? Ugh. Thanks. Okay, we're getting there. We're getting there. Right. Let's just see if that blends. Like, at least it will try and build the compute shader and tell us if that works or not. I mean, it won't tell us if it works, but it'll tell us if it yeah. Should be able to reflect all that out. I'd be shocked if this doesn't die. Yeah, thank you. Bleh. What is all this? All right. So it is uniform. Oh. Oh, wait a minute. Is this because I need the extension? Let's see what else we have wrong as well while we're here. What else did it not like? 12, which will be now 13. Unknown layout. binding. What? And then yeah, but oh, you think the errors might just percolated down from there? Oh, has it? Ugh. You can tell that is how often I use macros. Never. They are the worst. Right, here we go. 16. Unknown layout specifier. Does that not work in this land? It's not a layout specifier, right? It's a binding. What have I done wrong? Oh, it should be location. Ugh. Again there. Unable to find compatible OO function image load. Okay. What do they do with image load? So they passed in a they did pass in a sampler. Image load, here we go. Can I not do it with a sampler? Specify the image unit from which to load a texel. Specify the coordinate. Yeah, pass in an IVEC2. There's the texel coordinate of an image unit image. Thoughts? So the image. I see that's an image. There's also texel fetch. Sure. Okay, right, well that, it accepts it. So now let's see if we can dispatch it. So back to OpenGL gubbins. So we've got that. So where do we want to do this? You need to do it before the tone. Yeah, I've got to do it before the tone mapping, right? So that's going to be after the light pass here. Because I want to use it as an input into the tone mapping. So presumably I've got to do it before then. So presuming I can do Luminance histogram program.use. Do I need to clear that data? Yeah, presumably because I have to reset it before. So I need to new function unlocked. Named buffer GL clear named buffer data GL clear named buffer data. Right, which is, oh, hang on, I've lost it. This clear buffer clears individual buffers of a frame buffer. So I guess because you can't use GL clear because it's not a frame buffer, this is the equivalent of that, which is nice. So we can do GL clear named buffer data, and then this will have oh, that's the wrong page. I think there's a different one for clear named buffer. This will be the Luminance histogram buffer dot native handle. I'm assuming the flags are largely the same. Specify the buffer to where is this? GL clear named buffer data. GL clear named buffer data. Here we go. Right, sorry, wrong page. The internal format, that's what I need. What is the internal format? It's going to be 32 UIs, isn't it, if they're uints? GL R 32 UI. What is the next one? Type. The type of data in memory accessed by data. Can you give me any more? Oh, I think this wants. There you go. Initially specifies the format specified by format and data type is red. So I think looking at. Yeah, I found this here. So GL red integer, because I think it's only one component, right? You're not doing part of an array or anything like that. GL unsigned. There's a lot of runes here. Const auto 0 equals GL uint 0. 0. I've never really used Radari. I must admit, I'm more of a GDB person, but I know people who use it and say good things about it. So, okay, so let's clear the data. Okay, and then I need to set all those uniforms, don't I? So, what uniforms did we have? We had 3. Let's so. And this is of the Luminance histogram program. And again, we want the light pass data because we want it pre-tone mapped. And then these what values are they using for these min and max log values? They have not said. I've used IdaPro when I was doing reverse engineering, sort of, I guess, professionally. But since I don't do it as a job anymore, I have to do it as a hobby. I prefer Ghidra because it's free. Okay, I'm just going to have to run out of time. I'm just going to have to ask the Oracle. What? Give me the... Okay. Okay, I have some numbers. I don't know if they're correct, but the Oracle has blessed me with some numbers. GL program 1F. Luminance histogram program dot native handle. Minus 10.0f is apparently a sensible minimum. We'll need to put these into sliders, I imagine. And the index that is 1u. Indeed. And we are not to argue with the Oracle. Nope. Apparently 2. I guess as good as mine, mate. Okay, fine. Okay, so we're going to set those uniforms, and then we need to dispatch the compute. So we need to do... Oh, God. GL dispatch compute. Yeah, I'll dispatch compute. GL dispatch compute. And then this is going to be... No, I don't need to change the input tone map because that's still going to this will become an additional input to it later after we've calculated the final luminance value or the average value. For now, it's just we're just going to execute it and just check it works. So the number of work groups to be launched. So this is the static cast uint32t light pass rt dot fp dot width, okay, plus 15 over 16. So that will get us the width in terms of 16 blocks. This will get us the height in terms of 16 blocks, and then there's just 1 on the end because we've got no negative dimension. And then we will need to... Oh, Jesus Christ. GL memory barrier proc. GL memory barrier. GL memory barrier. GL shader storage barrier bit. GL buffer update barrier bit. So this will just make sure that the compute shader is finished before we try and consume the value. Not that we're trying to consume the value at the moment. Quickly just see if this runs. And then the whole thing doesn't go bang, and then we will super quick see if we can pull the values out and see if they adapt in real time, and whatever happens, we'll stop it after that because I need a beer and to get some sleep. Okay, well, we're compute shadering. We are compute shadering. So now now I just need to see if I can pull out that data and stick it in like a histogram or something. How do I pull it out? I assume I'm going to need to copy it. How do I copy data? Is it GL? Oracle. Just going to shove more stuff in the debug renderer. Oh, man, it's even giving me some ImGUI example code as well. Yeah, I've been trying to work out how much I want to commit to that no AI thing, because it's still useful for me to like double check stuff and generate stuff. I feel like I maybe was going a bit too hard on it before, because it's a little bit disingenuous to say I don't use any. I think no vibe coding might be better. So I did have to think about this before. Okay. So all the data should have been done at this point. And then we want to have I guess like the uint32t histogram 256. I know, I am the worst. And then GL get bugs. It's my own fault. Buffer sub data. Okay, get names. So this will allow us to pull the data out of that, which is slow, but we don't care because it's only in the debug layer. GL get named buffer sub data. Luminance histogram buffer dot native handle 0. Size of histogram. Histogram. Oh, I'm glad you're here, and I'm glad you're enjoying it. Okay, so I'm gonna pull the histogram data out of the GPU, and now I'm gonna try and render it. So it reckons the data could be quite. I should take the log2 of the data. Surely I don't. I guess you could, the values could be quite big, right? Because if you're looking at a pure white screen, you're going to have only one bin full, and it's going to have 192 by 1080 pixels in it. So I guess it does make sense to do that. So let's do histogram pipe to std views transform const auto e nope, try again. Const auto e return std log2 of static cast float e plus 1.0f, so we don't ever do it by 0. Std ranges to std vector. Yeah, I ask LLM some clarifying questions, but I'm not using like code generation basically. Right, so apparently now im GUI there is a thing. Luminance histogram dot hang on. Once auto scaled histogram histogram dot data 256 bins 0 sure null pointer not f not is that going to accept that and then imvec 2 im GUI get content region available dot x 150 point. I think that just scales it. It'll always be 150 tall, sorry, but it'll scale it outwards. And then this should be this should be stud max scale histogram. See if this works. Oh, we've been raided. I'm waiting for it. I'm waiting, like a long compile time. Like a long texture load time. Right. It's not great. Why is that? Why are they all 0? I think that might be a problem to solve for next time, because that's going to involve debugging it all. Do I never set the... Oh, ooh, the plot thickens. Once again, I have failed to set my luminance history, luminance dot native handle. Oh, amazing! That's whoa. 380 people just showed up right as I failed to buy my buffer. What a great time to join. Also, Cakes77, you just released the tower defense game on Steam, right? You did the whole thing in Scratch and C++. Congrats! What a great achievement. I hope one day get that myself, if that is who I'm thinking of. If not, I've just thanked a random person on the internet who deserves the thanks anyway. Indeed, Tandy TD. Go check it out on Steam. I think anyone who's writing games from scratch in C++ deserves some support and love. Right, am I doing this right? Am I making this up as I go along? Have I lost all rhyme and reason to my life? Binding 0. I haven't even bound the bloody textures. What am I doing in my life? So that's one. Where's the texture? Where's the textures? Textures. Scene textures there. For the first time ever, Twitch people have eclipsed the number on YouTube. So YouTube guys, you gotta step your game up. You're gonna find some friends and bring them along. Let's see if this works. We're having some issues on Twitch. I don't know if it's my end or their end, but I do apologize. It's still not great. Got one really big value there, and then one slightly small value, and an absolute sweet FA between. It's sort of, does that one bin change? It's sort of changing as the brightness is coming in and out, right? I'm streaming 4K on Twitch. I didn't know that. I only stream in 1080p on YouTube. I don't even know if I could. I'll have to check the settings on the plugin. How do I? I have no idea what I'm doing. I'm a professional streamer. Right, I'll look at that for next time because I should only be a dual encode locally and stream out, but it should only be 1080p in both. But yeah, I'm kind of curious why this is not doing it. So if I whack the contrast, not contrast, if I whack the gamma right up, or if I just add loads of lights. There's got to be a bug in the compute shader somewhere. I think that's all the missing bits, right? Let's just double check. We've got the three uniforms. No, I'm pretty sure I set it to 6K for both. I don't know, change the settings as I'm doing it. Bitrate is 6K. It's probably the Twitch server default advanced settings. It says it's just using the main encoder, but the main encoder general settings video. Oh shit! No, I do have it set to 4K. Fuck, sorry, that is my bad. Because I was doing some screen recording in 4K, and I forgot to set it back. No, that is my bad. It's because I don't know what I'm doing. But I was doing some screen recording for a video, and I was recording it for 4K, and I forgot to. I was like, I always must lower it before I stream. Apologies for a terrible experience. Also, I'm about to finish anyway because my brain is absolutely dead, and I think I need to take a step away from this and fix this in slow time. But let me just add Luminance histogram compute shader, and then add extra OpenGL functions. Yeah, apologies. It's my fault. I'm terrible. I'm the worst. So let's support compute shaders. And then dispatch compute shader. Okay. I'll be better for next time. Okay, hang on. Well, everyone numbers are rapidly dropping anyway because they realize that I don't know what I'm doing. until I'm about to finish anyway. Thank you. Okay. I think it was actually quite productive today. We got tone mapping in, which was nice, and we got quite far into doing a compute shader. Seeing as I've never written a compute shader before in my life, like the fact that it definitely compiles and executes it, doesn't execute it correctly. Well, sorry, it executes it correctly. The compute shader itself is incorrect. I think that's too bad. I think that's pretty good. Right, so before everyone disappears, future plans, because this is important. I am attending, like a massive nerd, I'm going to the ISO WG21 meetup next week, which is going to be, I'm actually kind of really looking forward to. It also means that I'll probably meet some people from the community in person, which will be exciting. Yep, we're going to sit in a room with no windows for a week and talk C++. I am going to attempt, because I'm going down Sunday, I'm going to attempt to stream from the hotel. Okay, so my laptop, my terrible old laptop, runs UFPS, like it totally runs it. I'm going to try and import all my OBS settings over, and I'm going to, on the shitty, like, upload limit capped hotel Wi-Fi, I'm going to try and stream from the hotel room. It's definitely Sunday. And then, to be honest, like if I'm bored, maybe just like sporadically in the week next week. Yeah, if not, I'll tether to my, I'll try tethering to my 5G phone and see if that fixes it. It could be an absolute disaster, but could be fun. I don't know. I didn't want to say no on Sunday. I thought at least give it a go. Yes, I'm thinking we might not be able to dual stream. So yeah, we might have to downgrade to 720p, 30 FPS, and it might just have to be on YouTube. Let's give it a go. Let's see what happens. Like, it's just text on the screen, right? Can't be that bad. But I'm gonna bring my camera and my mic. So at least the chance of the maximum chance of the quality being good. We'll see. It could be a total disaster. It could be a total shit show, but I think it'll be fun. Yeah, that's all I got. Go to Discord. I've given up being polite. We might just spend the first hour troubleshooting, and you know what? C'est la vie. Other than that, I'm gonna have a beer, hang out on Discord for a little bit. New video soon-ish. It has, I don't know the best way to describe it. One or two things out of external dependencies that I need to resolve before I can publish it, but it's pretty much done. Other than that, I'll see you all anon.